PGP1.
So this is the DC jack in the motherboard, PGP1.
We have the PL24 inductor.
The PL24 inductor, this one, next to the DC jack.
This is the input inductor. And over here we have two MOSFETs or switches. This is the first MOSFET, PQ51, and the second MOSFET, PQ52.
So this MOSFET is PQ51, and in the other side we will find PQ52. This is PQ52 MOSFET, always next to the DC jack.
So basically this MOSFET is used for protection, and this one we called it a switch because it let 19 volt to pass from this side to this side. We have the current sense resistor, PR351.
Here we have the current sense resistor, PR351, next to the battery connector.
The purpose of the current sense resistor is to calculate the current consumed by the whole motherboard. Here we have the charge IC, PU17. Its reference is ICL6251.
This is the charge IC, we have PU17. And for the reference, as you can see, we have ICL6251.
We have the SIO. This is the circuit that is responsible for the management of the whole power in the motherboard.
This is the SIO or the super IO.
So here we have two voltage regulators that will generate the 12 volt to charge the battery. Then here we have the MOSFET or the switch for the battery, and also its inductor, PL45. But this channel will only work when the adapter is removed. So now let's see how voltage travel in the circuit step by step from one point to other points. First of all, we have the Vin. So Vin equal to 19 volts. The Vin will pass through this inductor and it will be present here in the drain of this MOSFET, PQ51. So let's check PQ51.
So this is the MOSFET. As you can see here, we have PQ51. Okay, this reference PQ56 is for this MOSFET. Okay, here 3-pin MOSFET, but PQ51, this is it. Here we have this dot, means this is the source, and over here we have the gate, and this is the drain. We have to find 19 volt is in the drain. So let's check. We have 19 volt in the multimeter.
So we find 19 volt. 19 volt is present. Then 19 volt will go in this direction, as you can see, and in this direction to power this IC. We have here the DC in. So the DC in signal is about 19 volts. It is the working voltage for this IC. So without the DC in, the IC will not work, means we will not get 12 volt, we will not get anything in this circuit. So let's check the DC in the pin 24. We have to find 19 volts.
So this is the charge IC. This dot here means this is the pin number 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we have 12 and over here we have 12. So the pin 24 is this one because the reading is like this, counterclockwise. Okay, 1 we have here 1. This is the pin number 12. Here we have 13, 14, 15 until 24. So this pin is the pin 24. So let's check this pin. We have to find 19 volt in the multimeter. This is the DC in. Let's check. We have 19 volt in the multimeter. So the DC in is correct.
Good. So once we find 19 volt let's see the next step. So here we have the first step. So this is the second step. The third step is the 19 voltage will go in this direction, as you can see. Of course, it will pass through this resistor, PR359, and it will be applied to pin number 3 in the charge IC. So because we have these two resistors about 100 kilo ohm, we will not get 19 volt here like the DC in. We will get a voltage usually between 1.2 volt and 3.3 volt. So let's check in the IC.
So this is always the charge IC. Let's locate the pin number 3. So this is the pin number 3 here. So 1, 2, 3. This pin number 3 is connected to this resistor. Do you see this part here? This small part means we have connection. So let's check here in this resistor. We have 1.3 volts.
We find 1.3 volt. So this step is good, and the third step also is good. Next, once the charge IC get these two signals, this is basically two input signals. We called it also enable signals. Once it get these signals here, this one and this one, it will then generate the EC drive. So this is the step number 4. The EC drive will activate these two gates. Then the 19 voltage will pass in this direction. But let's first check EC drive. So for EC drive, it's about 8 volt. So let's check the gate of this MOSFET PQ51 and this MOSFET PQ52.
So let's check the AC drive in the motherboard. We have to find 8 volt in the gate of PQ51 and PQ52. So let's check first the gate of this MOSFET. So here we have this dot, means this is the pin number 1, 2, 3 and 4. So the gate always is in the pin number 4. So let's check pin number 4. We have to find 8 volts. As you can see in the multimeter, we have 8 volt. So the AC drive here is good. Let's now check the other MOSFET PQ52. So the second MOSFET is in the other side of the motherboard. So we have here PQ52. So this is the gate, because here we have this dot, means these 3 pins are source, and this is the gate. Let's check. Also we have 8 volt. So the AC drive is good in both MOSFETs.
So I will prove to you why generating the AC detect or the EC in, we called it sometimes AC set or also enable. We can call this signal enable. So this signal is very important. Without this signal, the AC drive will not be generated. Let's see the proof.
Please pay attention. This functional diagram is apart from the charge IC. Do you see here the gate signals, these 2 signals? In order to be generated, this IC should receive this enable signal. So this enable signal will activate this IC. And then this IC will generate an output to activate this IC, and then this IC will generate the control signals, as you can see, for the gates. So in our case, the enable here is the AC in, about 1.3 volts.
So once we find 8 volt in these 2 gates, means these 2 MOSFETs are activated. So a 19 volt will pass here. We will get here 19 volt. So this step also is good. 19 volt also will pass through this current sense resistors, and then we will get B plus 19 volts. Let's check 19 volt in both sides of this current sense resistor, PR351?
So we have the current sense resistor PR351. Let's check 19 volt in both sides. So here we have to find 19 volt. This is good. Let's check the other side. We have 19 volts.
So once we find 19 volt in both sides of this resistors, why in both sides? Because resistance is about 0.02 ohm. So the B plus is good. So this tip is good. We get the B plus. From here, the voltage will be distributed to the whole circuit of the motherboard, including the CPU circuit, the RAM circuit, etc. So let's check if this B plus is distributed to the whole motherboard or to the whole circuit in the motherboard.
So now we gotta check if the 19 volt is distributed to all circuit in the motherboard. So let's begin with this circuit. Here we have this inductor. We have to always locate this inductor. We have to find 19 volt. We have 19 volt. This is 3 volt, 5 volt circuit. Here we have the NOT bridge circuit. Let's see if we have 19 volt or not. We have 19 volt. Also here we have the CPU circuit. Let's check this inductor. We have 19 volt. Let's go and check the graphic card inductor. We have PL, means this is inductor. We have to find 19 volt. This is good. Let's go ahead and check the RAM circuit. We have PL inductor here. Let's check. We have 19 volt. Why I check 19 volt in this kind of inductors? Because those inductors are always in every input for every circuit. So the 19 volt is distributed to all circuits in the motherboard.
Good. We find that the B plus is distributed to all circuits in the motherboard. Means this step also, the step number 6, is also good. The distribution of the main voltage is done 100%. Now the 19 volt will pass through these inductors directly to source of this MOSFET, PQ53. But it will stop here in the source. It will not pass to other side, because if it's passed to this side, it will damage the battery, because the maximum voltage of the battery is 12 volt. Why the voltage will not pass to this side? Because this MOSFET contains inside it a protection diode that will not let the voltage to pass in this side. So let's check this MOSFET. We have to find 19 volt in its source, but the drain we should find 0 volt. So let's check in the motherboard.
So this is PQ53, as you can see. Here we have this dot, means this is source. So we have to find 19 volt in the source, as you can see in the multimeter, but in the drain we have to find 0 volt, as you can see.
So here it's a good MOSFET. The battery is protected. So the next step here is this. The 19 volt will travel in this direction. So we will get 19 volt here in the drain of PQ62. So this is the step number 7. Let's check the drain of this MOSFET, PQ62.
So we have here PQ62, as you can see. So this is source. You have to always locate this point, because the point always refer to the pin number 1. So 3 pins here for source. This is the gate, and over here we have the drain. So we have to find 19 volt in the drain. Let's check. We have 19 volt in the multimeter.
So the 19 volt is present. Means the last step about the main voltage is good. Now let's move on to the next chapter. So once the charge IC detects or receive the DC in, the AC in, and also the B plus is here and is distributed to all circuit in the motherboard. The charge circuit will begin send the ECO key to this IC, to the super IO, about 3.3 volts. So let's verify the ECO key in the motherboard.
So this is the SIO, as you can see, near to the charge IC. So the ACO key exists in the pin 127, as you can see in the schematic. So let's check the pin 127. So as you can see, this mark here means this is the pin number 1. Over here we have 32, the pin number 32, 33, here we have 64, here 65, here we have 96, 97, and over here we have 128. So the pin 127 should be this pin. So we have 3 volt in the multimeter, so ACO is good.
So we find the ACO means the number 8 is good, the ECO is good. So the ECO that the charge circuit sent to the SIO is the same as power good. The charge IC here inform the SIO because this is the bus. Here we have bus. So this is the big bus in the charge circuit. Always the charge IC refer to its bus. That's why this IC is the IC that manage the whole power in the motherboard. So the charge IC will inform this bus that the AC in is detected, the DC in is detected, and also the main voltage is distributed correctly. So then the SIO will send another signal here. Basically this is SMB data, okay, and also SMB clock, the same as those, but those signals will be sent to the battery. Okay, we're gonna discuss these signals after. So after receiving the ACO key, the SIO will send the SMB data and SMB clock signal to this IC to generate the upper gate. Here we have 10, okay, here also we have 10, okay, to generate the upper gate to these two MOSFETs. We have PQ62 and PQ64. These two MOSFET will then generate the 12 volt to the battery. Here guys, I have a question. Why we always speak about 12 volt, not 19 volt or 18 volt? Why? So let me explain to you and teach to you how the battery works in order to understand why 12 volt and not 19 volt. Let's get started. So do you see here? Basically the battery for the laptop composed of 6 cells. Okay, we have these 3 cells are connected in series. Okay, and for each cell we have 3.7 volts, 2 amps, 3.7 2 amps, 3.7 2 amps. So when we connect the cells in series, means the voltage will be added, will be increased, but the current will remain the same. So means we have 3.7 here, 3.7, 3.7. So 3.7 plus 3.7 plus 3.7 equal 19.1 volts. Means 12 volts. Okay. We have another arrow here where we have 3 other cells. Okay. So these 3 other cells also is in series. Means we have here 12 volts, 2 amps. Okay. And here we have 12 volts, 2 amps. Because those in series and those in series. Now the 2 arrows is in parallel. Means what? When we have 2 blocks of cells in parallel, means what? Means the current will be added, means 2 amps plus 2 amps will be 4 amps. Okay, we have here 4 amps. But in parallel, the voltage will not be added, will remain the same voltage. Means we have here 12 volt, 12 volt, it will be 12 volts. So within the battery, we have 12 volt for amps. That's why these two voltage regulators generate 12 volt, not 19 volt, not 18 volt, because the maximum voltage that the battery can support is 12 volt based on its configuration. 6 cells with the characteristics of 3.7 volt, 2 amps.
Let's track voltages in the motherboard. Let's put the black probe of the multimeter into ground. In the motherboard, we have ground everywhere. This is ground. This is ground. Here also we have ground. The negative terminal of the capacitor also is ground. This also could be used as ground. So let's select this ground, for example. Let's put the black probe here and then check the DC connector first. We have to find 19 volt here. As you can see, we have 19 volt. In this side also we have find 19 volt, as you can see in the multimeter. Then this is the MOSFET or switch. We have to find 19 volt in the source. We have 19 volt. Why DC source? Because as you can see here, we have this dot here, means this is the pin number 1. So 3 pins are for source. And this is the gate. In the gate, basically, we have to find 8 volt. So let's check. We have 8 volt in the multimeter. So once we have 19 volt here in the source, and we have 8 volts in the gate as the control signal, so 19 volt should pass to this side, to drain. Let's check the drain. We have 19 volt, as you can see. So the 19 volt or the VIN is good for this motherboard. So because here we have the DC connector and the battery connector, means this is the charge circuit. Here we have the charge IC, and over here we have the super IO, the IC that is responsible for the whole power in the motherboard. So without wasting time here, let's go directly to the current sense resistor and check 19 volts. So let's see the back of the motherboard. So this is the current sense resistor. The current sense resistor is the point where the voltage will be distributed to all circuits in motherboard. So let's put the black probe in the ground once again and check this current sense resistor. We have to find 19 volt, as you can see in the multimeter. This inductor also should hold 19 volts. Why? Because it is connected with the current sense resistor. So from this point, the 19 volt or the VIN, because it could be 19 volt, it could be 18 volt, 15 volt, 12 volt, 9 volt, depending on the type of the motherboard or the laptop. So from this point, the VIN will be distributed to all circuits in the motherboard. I will prove for you right now and then continue tracking voltage. So to prove to you why the voltage will be distributed from this point to all circuits in the motherboard, let's put the multimeter to the continuity option or buzzer option. Here we have the continuity option. So the multimeter is seated correctly to the continuity option, and you can check by connecting these two probes each other, as you can see. So before checking continuity in the motherboard, let's first unplug the connector. Then let's put one probe here in the current sense resistor and check all circuits in the motherboard. Let's check, for example, the CPU circuit. This is the input. Always this inductor means input. Do you see? We have low resistance. Means this point is connected with this point. Let's check this circuit also. This is the NOT bridge or chipset circuit. As you can see, means this point is connected to this. Let's check this circuit also. This is 3 volt, 5 volt circuit. as you can see, means also this point is connected to this point. So let's check another circuit. Here we have this inductor. This is the graphical circuit, as you can see, means this point is connected with this point. Here basically we have another circuit. This is the RAM circuit, as you can see. So this current sense resistor is connected with all circuits in the motherboard. So many of you will ask how I know all these circuits. Easy guys, stay tuned and I will teach you how you can spot any circuit in the motherboard and differentiate between the CPU circuit, the graphical circuit, the NOT bridge circuit, the memory circuit, the 3V 5V circuit, the charge IC circuit, etc. Please stay tuned. At the end of the video, I will teach you this circuit and how you can know about it just visually. So once we check the connection between the current sense resistor and all circuit in the motherboard, let's plug again the adapter and continue tracking voltages. So the black probe in the ground, but don't forget to set the multimeter again to 20 volts. So the multimeter is set to 20 volts successfully. So the black probe in the ground, we have 19 volts here in the current sense resistor. If we move directly to this circuit, this is 3V 5V circuit. If we check this inductor, we have 19 volt. And if we move to NOT bridge circuit, here we have inductor, we have 19 volt. Please remember that always this inductor refer to the input of any circuit. Let's move on to the next inductor, this one. Here, this is the CPU circuit. Those are MOSFETs. Those are capacitors. So let's check. We have to find 19 volts, as you can see. If we move on to the next circuit, this circuit is the graphical circuit. We have this inductor. We have to find 19 volts. And let's move on to the next circuit. Here we have the RAM circuit. If we check the input inductor, we have 19 volts. Magic? No, it's logic. Just stay tuned. You're gonna understand everything. And please don't forget to like the video and share it with your friends and other interested people like yourself. We have this white mark over here, means over here we have cathode and here we have anode. So we're gonna put one probe here in the cathode and the other probe in the anode. We get a reading in the multimeter. This is a good diode. Always for the MOSFET between drain and source, you should get a reading, as you can see in the multimeter. Do you see? The capacitor charge and discharge means this is good capacitor. If you use the continuity option, you will find about 0 in the multimeter, or you can test it using the resistance option. So if I check this resistor, I can find about 1 ohm. It could be less or it could be high a little bit, 1.2, 1 ohm or 0.9 ohm. Do you see? 1 ohm, about 1 ohm. So this is a good current sense resistor. Here we have another current sense resistor. If we check it about the same value, 1 ohm, 1.1, let's check. We have 1.1, 1 ohm, 0.9. So this is good. The dot means this is what? This is here the emitter, collector, and base. So for transistor, between emitter and collector, we should get a reading, as you can see. If we swap the probes, normally we should not get anything, as you can see, nothing. Okay, the same for this one. So we have this dot, means this is emitter. So between emitter and collector, nothing, good. But if I swap the probes, I should get a reading between collector and emitter. Let's check. I get a reading about 600. For ceramic capacitor, we should get a high reading, as you can see in the multimeter. If you get a short or a low reading like this means the capacitor is shorted, or the IC near to the capacitor is shorted. Let's check those also. Good. Hi everyone, so welcome again to another strong video where I'm going to teach you how to test all this component in this motherboard one by one. So I'm going to teach you how to test every component here using, of course, the multimeter, and of course in the other side of this motherboard. So please stay tuned, because this video will help you a lot during your hardware repair. So without wasting time, let's get started. So first of all, I'm going to select the continuity option, and of course here we have the diode option, because this is the option that we're gonna use to test the majority of component in the motherboard. So as you can see here, this motherboard is for HP, and over here we have the input or the DC input, and here of course we have the diode. So let's begin with this diode. So here we have this white mark over here, means over here we have cathode and here we have anode. So we're gonna put one probe here, as you can see, in the cathode, good, and the other probe in the anode. We get a reading in the multimeter. This is a good diode. Of course, if we swap the probes, normally we should not get anything in the multimeter. This is good. So this is a good diode. This diode basically is used for protection. Then over here we have a MOSFET. This is a 3-terminal MOSFET. Do you see? 3-terminal MOSFET. And over here we have 8 MOSFETs. I'm going to test all these components just step by step. So here we have gate, as you can see over here. We have drain and source. So always for the MOSFET between drain and source, you should get a reading, as you can see, in the multimeter. If we swap the probes, as you can see, we didn't get any reading. Means this is a good MOSFET. So please guys, I'm going to teach you right now. I teach you how to test component very fastly. Okay, so this course or this video will be very important, especially for beginners. Please do not skip any moment in this video and stay tuned until the end, because I'm going to check all these components in this motherboard, okay, in the entire motherboard. And of course, I show you how to test the majority of components using just the continuity and the diode option in the multimeter. So let's check this capacitor. Basically here, if you focus here, we have 220 microfarad, 6.3 volt. This is the characteristics of this capacitor. Okay, so note that this is a polarized capacitor. Do you see? We have here plus over here, and this color means minus. Here also for this one we have minus, and over here we have plus, minus, plus. So to check this capacitor, you can just put the black probe here in the negative terminal and the red probe in the positive terminal. Do you see? We get a reading in the multimeter. We didn't get a continuity like this. If you get a continuity, means there is a problem in the capacitor. This one also, for example, let's check it. We get a reading. This one also, as you can see, we get nothing. If we swap the probes, let's check. Do you see? The capacitor charge and discharge. Okay, the capacitor charge and discharge. Do you see? Means this is good capacitor. Do you see, guys? So this is how we can test this kind of capacitors. We called it electrolytic capacitor or polarized capacitors, because we have here plus and here we have minus. For this component, this is basically, we called it inductor. The inductor basically is just a wire. Okay, the inductor is just a wire. If you try to look here, do you see the wire here inside the inductor? means we should get a continuity while testing the inductor. Do you see 0 in the multimeter? Means this is a good inductor. If you didn't get a continuity or a buzzer like this, means there is a problem in this inductor, and you should of course replace it using the same reference, 2R5. For this one, for example, we have 2R2, 2R5. This one has 6R8, etc. This is the reference that you can use to replace those inductors. Now let's move on to this kind of MOSFET. This is basically 8 MOSFET, the same as 3-terminal MOSFET. But here, as you can see, you should usually or always locate the pin number 1. Do you see here we have a small hole, or of course you can use this dot. Do you see this white dot? This white dot means this is the pin number 1, pin number 2, pin number 3. Okay, so 3 pins for source. We can ever check these 3 pins. You're gonna find the continuity. Do you see? The first pin and the second and the third. Do you see, guys? We have continuity between these 3 pins. And this one, this is the gate, the 4th pin, and the other pins here are for drain. Also for beginners, we can even check the continuity. All these pins are connected together, as you can see. Okay, all those pins are connected together. So all these 4 pins are just like the drain here, and these 3 pins are like the source over here, and the gate, this is the gate here, and this is the gate. So to check this kind of MOSFET, easy, exactly like this MOSFET, as you can see. We can just check between drain and source, as you can see. We get a reading, means this is good MOSFET. For this one also, we can check between drain and source. We get a reading, this is good. Those also the same, we get a reading. If we swap the probes, we get a reading here. Also here, we get a reading, means these 4 MOSFETs are good. If you hear any buzzer like this, means the MOSFET is shorted. So for the inductor, the same as this one, we should get a continuity. Okay? Here we have the tantalum capacitor. We called this component a tantalum capacitor, and it's also polarized exactly like this one, as you can see, like the electrolytic capacitor. And over here we have the capacitance 227 microfarad. And over here this white mark means this is the positive terminal, and over here we have the negative terminal. Do you see? We get a reading, means this is good. We get a reading, means this is good. If we swap the probes, do you see charge and discharge? Do you see, guys? We have charge and discharge. Means also the tantalum capacitor, or this capacitor, is a good capacitor. Good. The ceramic capacitor is no polarized capacitor. Okay, so here we have a cross section of a ceramic capacitor. As you can see, it is composed of many layers. As you can see here, the insulation material between layers. Okay, so here, as you can see, we have the ceramic capacitor terminals. Okay, this is terminals. Okay, exactly like this. And of course here, this is the metal electrode. Okay, and here this is the dielectric or insulation materials. So now I'm going to show you how to calculate the ceramic capacitor code. So using the same working principle as the resistor. So the first and the second digits are fixed numbers. Okay, the third digit is the multiplier. Okay, so the third digit is the multiplier. But for the ceramic capacitor, the 4th digit or letter is the tolerance. So if you find J means 5%, okay, K 10%, M 20%. See an example. For example, let's say we have a ceramic capacitor with 104 K. So this code means 10 and 4 zeros, as you can see. So plus or minus 0.1 microfarads. So 0.1 microfarad, as you can see, is the tolerance, because here we have the K, so K 10%. Okay, so 10% of this number. We have here 3 numbers, so always, as you can see, the first digit, the second digit, and this is the multiplier. But if we have 4 digit, as you can see here, so the first digit, the second digit, we have the multiplier, the digit number 3, and the fourth digit is the tolerance. Okay, the tolerance, this digit have to be J or K or M. Okay, here we have some examples. So we have 1, 0, and 4 means, as you can see here, 100 picofarad. Okay, here we have 473 J, so means, as you can see here, 47,000 picofarad. Okay, and J, the tolerance is 5%. Always the ceramic capacitors are measured with picofarad, but for the electrolytic capacitors and tantalum capacitor, the unit is microfarad. So now let's see the symbols of capacitors. So basically there is 2 types of symbols. Symbols for polarized capacitors and non-polarized capacitors. So as you can see here, all the symbols are the same. So here, this is a symbol for a polarized capacitor, for an electrolytic capacitor. Here we have plus and minus. Okay, always the top terminal is the plus. Here we have plus and minus. So this is plus and this is minus. This is the positive terminal and this is the negative terminal. Okay, always the top terminal is the positive terminal. Here, as you can see, we have plus and minus, and here this is the positive terminal and this is the ground terminal. Basically, these 2 symbols, these symbols are a U key symbols, and those are a US symbols. Okay, so but for the polarized capacitor, we used usually this 2 kind of symbols, this and this. Okay, for non-polarized capacitors we have these 3 symbols, but we used usually these symbols, as you can see. So this is also a UK symbol, and here this is a US symbols. So but we use this usually. So as you can see, this 3 symbols doesn't have the plus and minus sign, okay, because those are no polarized capacitor. Let's see how to test capacitor. Of course, before diving into testing capacitors, I want just to add that the capacitors, as you can see, for the polarized capacitors, you should respect the polarity. I mean, you should always put the red probe of the multimeter in the positive terminal and the negative probe or the black probe here in the negative terminal. Okay, but for non-polarized capacitor, you can use the probes as you want. You can put the black hair and the red hair, or the red hair and the black hair. So as you can see over here, this is basically the ceramic capacitors that we gonna test using the multimeter. So I want just to say that you can find many types of ceramic capacitors in laptop motherboards and computer motherboards. For example, you can find this kind of ceramic capacitors, big ceramic capacitors. Also here we have other ceramic capacitors, as you can see over here. So to test the ceramic capacitors, we gonna use, as you can see here, the continuity option. We gonna use this option. Okay. So let's begin and test, for example, this big capacitors over here. So we can just put 1 probe here, okay, and the other probe into other terminals. Do you see? We get a reading here in the multimeter. We should not get a reading like this, as 0 in the multimeter. If we get a reading like this, means the capacitor is shorted. Okay, so let's check the second one over here. Okay, we have here the same reading.
You're going to understand 100% the CPU circuit. I will teach you everything about how to diagnose, track voltages, follow signals, etc. in the CPU circuit. So as you can see here, this is the CPU control IC. Here we have MOSFETs, 10-10 capacitor. So this is the first channel here, and this is the second channel. Do you see here this part here? This is the CPU IDs, because in order to generate the VCC core to feed the CPU, the IC should receive first these IDs, as you can see, and based on these IDs it will generate the control signals for these MOSFETs in order to generate plus VCC core. So let's first take a look to the CPU circuit and then go step by step on how to diagnose, how to track and follow voltages. As I told you, this is the IC. Here we have MOSFETs, here we have ceramic capacitors, this is 10-10 capacitors, and in the other side we have inductors. Okay, so each inductor means one channel. So this is the first channel and this is the second channel. So here always the ceramic capacitors means we have the input. We can ever check using the multimeter. So let's zoom out a little bit. So here we have the CPU circuit. Let's check if these ceramic capacitors are the input or not. So here we have the input. Do you see the power jack? As you can see here we have the first switch, the second switch. So if we check between this switch here, okay, and these ceramic capacitors, we get, as you see in the multimeter, very low resistance, and of course we get a continuity. Means this point, this switch is connected directly to the ceramic capacitors. Means here we have 19 volt, it will pass directly to this side. Of course, we select here the buzzer or the continuity option. So as you can see, these ceramic capacitors are connected to the input signals in this side, as you can see here, and to the ground in the other side. So here we have the ground. This wide area means the ground. We can even check if we put one probe here and put the other in the ground, as you can see in the multimeter. So here the 19 volt will pass through the ceramic capacitors to be filtered. Okay, so when capacitors are in parallel means they have filtering purpose, and when you find ceramic capacitors in series means they are used for coupling purposes. I'm going to explain to you everything in the next slides. So the 19 volt will pass through the ceramic capacitors and then goes to the drain. Here we have the drain. Do you see here? So we have the same path here. If we check between this MOSFET and those capacitors, as you can see, we have a low resistance. Do you see? Means we have connection. So this is the drain. For beginners, of course, the drain, all 4 pins are connected together, as you can see. So all 4 pins are connected together. So here we have drain, and these 3 pins are source. If we check, of course, for beginner, the 3 pins are connected also together, and we have the gate. Do you see here we have the gate? If we check this pin, we have to find a continuity with this IC. Let's check. We have to find a direct continuity, because this IC is the IC that controls that MOSFET. Do you see? We have a direct continuity between this pin and this pin. Even for this one, for example, here we have the gate. If we check also this one, let's check between the gate here and this IC. Do you see? We have also continuity. For 4 MOSFETs are controlled by this IC. So the 19 volt will pass to the drain, and then after receiving the control signal here in the gate by this IC, this voltage, the 19 volt, will
be transformed to plus VCC core. So VCC core is about 1 volt. Basically, it is between 0.7 volt and 1.5 volt. Do you see? The source of this MOSFET is connected to drain of this MOSFET, and then this MOSFET is connected to the ground. So I'm going to teach you how to test all components of the motherboard without removing it from the board. This is a very exclusive course. Please don't miss this video. Stay tuned until the end, because what I'm going to teach you will impress you. So let's begin with this capacitor. For example, we have 10 ohm capacitor. So let's check. We have a reading in the multimeter, means good. Let's check this one also. We have ready, good. So please, testing component is very easy. Let's check this diode. Here we have for diode, this is a Zener diode. We should locate the cathode. Here we have the cathode. Do you see this white mark? Means I'm going to put in the cathode the black probe like this and the red probe in the anode. We have a reading. If I switch the probes, let's see. Nothing. In the multimeter, means this is a good Zener. Let's check ceramic capacitors. Here, for example, we have ceramic capacitors. Let's check. So no continuity, no continuity, as you can see. So no continuity means this is good ceramic capacitors. So for inductor, of course, we should get a continuity, as you can see. We should get a continuity because the inductor is just a wire. Let's see the MOSFET. Here we have the MOSFET. So for the MOSFET, we should locate first. Here we have the source, okay? Here we have the drain. So if we check between drain and source, we should get a reading. If we swap the probes, we get also a reading. This is normal. Why? Because the MOSFET is connected to the board. But once we don't get a continuity like this, means the MOSFET is good. Let's check this MOSFET also. Let's check between drain and source. As you can see, nothing in the multimeter. If we swap the probe, we should get a reading about 400, 500, 600. Do you see? Good. So this is a good MOSFET. Let's check this MOSFET also, just to be sure. Here we get a reading. If we swap the probe, we get a reading because it is connected to the board. This one also, the last one. Swap the probe. Good. This is good MOSFET. Okay. What about the resistor? So we have here 103, means this is a 10K or kilo ohm resistor, because 3 here means 3 zeros. So this is 10K. So for resistors, we cannot test it using the continuity option. We should move on to 20K. Okay, always a value that is higher than the value here. So let's check. We should find 10K. Do you see? We have 10. We have 9 or 10K. So this is a good resistor. So let's go to continuity option and check this diode over here. Do you see, guys? This is diode. We have D21. So always for diode, we should locate the cathode and put the black probe into cathode like this and the red probe into anode. We get a reading in the multimeter. If we swap the probe, we should get nothing. As you can see, nothing in the multimeter, means this is a good diode. So here we have MOSFETs. So what about the IC, guys? What about the IC? How we can test the IC? So easy. You can test the IC by checking the ceramic capacitors around the IC. You see, we get a reading. Good. But if you get a short circuit like this on those ceramic capacitors, means the IC is bad, because usually the ceramic capacitors are connected to the IC in one side and to the ground in the other side. But please pay attention for the chipset circuits. Okay, so if we go back here, please pay attention. This is a very important. So here, this is basically the back of the processor. Okay, here we have the back of the processor. So I told you that for the ceramic capacitor, we should not get a continuity, as you can see in the multimeter. So this is good. But we have exception for the processor. Do you see? We will get a continuity, as you can see. Do you see? We will get a continuity. But this is, we have 13. This is normal. Okay, so this is normal for the CPU circuit. Please pay attention to this. This is not short. Okay, this is not short, guys. Okay, this is normal for the CPU circuit. Okay, but the same also here. If we put the black probe in the ground and check this inductor, do you see guys, we get a low, you see, we get a low reading. But if I remove this CPU, we will get a high reading. Okay, so do you see, now we have a low reading. So let's remove the CPU. So let me please remove the CPU. Okay, now the CPU is here. So let's check again the black probe in the ground and check. Do you see, we get a high reading. Here we get a high reading. This area here, green area, this is for ground, but those bold or thick line, this is for power, for voltage. It could be for 19 volts, 5 volts, or even for 3.3 volts. But this part here, as you can see, a team paths are for data. So we have the control signal is generated by this IC. Do you see here? Generated here and then pass through this resistor and then goes in this direction to the gate of this MOSFET. So this IC activates this MOSFET. So if the MOSFET is not working, means you should check here. You should check this resistor. It could be the bad component or the IC does not generate the control signal. You can just follow this path, okay? Please follow this path like this until here we have a point or a hole, means the path is in other side of the motherboard. If we go here, let's check. We have this IC. Do you see guys? We have the hole, the same hole. So this hole here coming from this connector is in the other side of the motherboard here. Means this MOSFET, this 5-pin MOSFET is the responsible of generating the 3.3 volts for the connector. So we have here a very clear example. Do you see this connector? Here we have this bold line here, means this is the connector for the fan to cool down the CPU. We have this bold line here, means the connector receive here 3.3 volt. But if you find that 3.3 volt is missing here, you can just follow this path like this, as you can see. So we have this transistor here. So this transistor is the component that generate this 3.3 volt. So if 3.3 volt is missing, you should check this transistor. It could be failed. But if you find that the transistor is good component, then you should check the 3.3 volt 5 volt circuit, because the transistor received the 3.3 volt from this circuit. So we can even check. So if we put one probe here in the 3.3 volt inductor and then goes directly to this transistor here, let's see. Do you see in the multimeter? We have 0, means there is a direct connection between this inductor and this transistor, as you can see. Okay, and then the transistor will generate another 3.3 volt here from this pin here, as you can see, to this connector, as you can see in the multimeter. So the component that we gonna use to detect the short circuit in a fast way is the inductor. This is inductor, this is inductor. Over here we have inductor. So in every circuit you will find inductors, as you can see. So the rule here is that the inductor can never be connected to the ground. So please write down. You can never find in the laptop motherboard the inductor connected to the ground. Never. We can even check using the multimeter. So let's select the continuity option here, as you can see. So let's check if the multimeter is seated correctly. Go to the continuity option. So if we put, for example, one probe here in the ground, here we have ground, here ground, here ground, everywhere is ground in the motherboard. If we check this inductor, do you see?
you can never find a continuity, a direct continuity between inductor and ground, because the inductor can never be connected to the ground in a laptop motherboard. Means if you find any shorted inductor with the ground, means in that place or in that circuit there is a short circuit. So I'm going to use the multimeter and check all inductors in this motherboard. If you find any inductor that gives like this reading in the multimeter, means we detect the short circuit, and then after that we can spot the bad component or the exact shorted component. But first, let's take a look in 1 minute to the schematic in order to prove to you that the inductor can never be connected to the ground. As you can see here, we have the schematic. This is basically the 3 volt 5 volt circuit. Do you see? We have here 3 volts. Here we have the controller IC, we have 2 MOSFETs, we have inductor or coil, we have capacitor. Okay, so here we have inductor. Do you see? Inductor is always exist in the power rail. Do you see? No ground here. So the capacitor here, the electrolytic capacitor is connected to the ground. This is the ground. This resistor connected to the ground. We have this MOSFET connected to the ground. This capacitor also the IC connected to the ground. But do you see? The inductor always connected to the power rail. Even here in the other side for 5 volts, here we have 5 volts, we have the inductor. Exist always in the power rail. Means if you find a short circuit or a short between the inductor and ground, means you have a short circuit in this channel. Okay, this is good. Let's see another circuit. For example, here we have an inductor, here we have 1.5 volt. This is for the RAM. Do you see the inductor? Inductor always in the power rail. Good. So let's now use the multimeter and check all these inductors one by one. First, let's connect the black probe to the ground and then check all these inductors. Let's begin with this one. No continuity, no buzzer. Let's see this. No continuity. Okay, let's move on to the RAM circuit over here. So good, this is good. Then let's go to this inductor over here. No continuity. Then this inductor in the battery circuit. No continuity. Then these 2 inductors belongs to CPU circuit. We have a continuity, a buzz in the multimeter. Let's check this one also. Means we have a short here. No guys, this is not short. This is the resistance for the CPU. Okay, so please pay attention. The inductors near to the CPU always gives a low reading. If you remove the CPU, for example, you will get a high reading. But because the CPU here is integrated with the motherboard, I will use another motherboard to show you this trick. So here we have another motherboard. Do you see, guys, the same working principle? If I put the black probe here in the ground, okay, and I check this inductor, do you see? Always, and check this inductor, do you see? Always we get a high reading in the multimeter. Okay, but if we go to the CPU circuit, do you see? We get a lower reading. Okay, this is not a short. I will prove to you why. So let me remove the CPU. So let's unscrew the CPU like this, as you can see. So let's now remove the CPU, as you can see. You see, the CPU is removed. Let's check again. So the black probe in the ground here, and check this inductor. Do you see in the multimeter? We get a high read. Means this is not a short circuit. Okay?
if we put back the CPU, as you can see, let's check. Back. We have a low reading. I can even make it easy for you. So do you see? If I open the CPU, do you see? High reading. If I close the CPU, low reading. Open, high, close, low. Do you see, guys? Means this is not a short circuit. The low reading is for the CPU, not a short circuit. Once we have the connector here and the battery connector, means this is the charge IC. So the first step is to check 19 volt in these two pins. Do you see here we have two red lines, means these two pins should hold 19 volt, and this is ground. Always the black probe in the ground. Here we have the ground, here also we have ground, and also we can use the negative terminal of the electrolytic capacitor. So the black probe in the ground, here for example, and let's check 19 volt in the first pin. We have 19 volt in the multimeter. Let's check the second pin. We have 19 volt. Means the main voltage is present. The second voltages that we gonna check is 3.3 volt and 5 volt. Here we have 3 volt, 5 volt circuit. You're going to find it usually near to the charge circuit. And of course, the charge circuit is always near to the battery connector and DC connector. So here we should find 5 volt in one inductor and 3.3 volt in the other inductor. So let's put the black probe in the ground here. Let's check, for example, this time the negative terminal of the electrolytic capacitor. So let's check this inductor. We have 3 volt, as you can see, 3.3 volt. This one should be 5 volt. Let's check. We have 5 volt. Means the 3 volt, 5 volt circuit also is good. So we have find the main voltage and the 3 volt and 5 volt circuit. So this is the charge IC, this one, and over here this is the 3 volt 5 volt IC. So for 3 volt 5 volt circuit, you're gonna find always two channels. The first channel for 5 volt and the second channel for 3.3 volt. So you can take measurement here in the inductor, we have 3.3 volt, or in the electrolytic capacitor exactly in the positive terminal. As you can see, we have 3.3 volt, or here in the test point. Do you see this? This is pad or test point. Let's check. We have 3.3 volt. So this is 3.3 volt channel. And this is 5 volt channel. We can find 5 volt here in the inductor or in the positive terminal of the electrolytic capacitor, or easily in the test point. Okay, so this circuit also is good. This is the super IO. This inductor always hold 19 volt. Let's check. As you can see in the multimeter, always this kind of inductor holds 19 volt. If we check this inductor, we gonna find 19 volts. As you can see, this inductor we gonna find 19 volts. Let's see another inductor. For example, here we have another inductor. It have to hold 19 volt. Let's check. As you can see, we have 19 volt. I will explain you how. So let's take a look to the schematic of this motherboard and then continue checking voltage in order to understand why this inductor always hold 19 volt. I will show you how. So in this circuit, for example, we have two inductors, as you can see. So basically this is the circuit that generates 1.5 volts. it contains two inductors. An inductor in the input, because here this is the input. Here we have B plus 19 volt will pass in this direction and goes to this MOSFET, and then we will get here 1.5 volts. So this is the input inductor and this is the output inductor. So this inductor is this one, and this inductor is the big one, this one. So let's see, for example, the 3 volt 5 volt circuit. We have here two big inductors and we have an SMD inductor in the input. So this is 3 volt 5 volt circuit. Here we have 3 volt and over here we have 5 volt. So this is the channel for 5 volt. We have two MOSFETs, inductor, capacitor. The same for this channel also, 3 volt. We have two MOSFETs, inductor, capacitor. Let's zoom in a little bit. We have, as you can see, PL47 in the 5 volt channel. We have PL47, as you can see. So if we check this inductor, we should find 5 volt, as you can see. And the second inductor in the schematic is this one, PL46. We have here PL46, as you can see. The same, this inductor is for 3.3 volt. And we have another inductor in the input. This is it, PL48. So this inductor is in the input, PL48. So let's check the back of 3 volt 5 volt circuit. This is it, as you can see, PL48. So this hold 19 volt, exactly as we have in the schematic, B plus. So always this inductor exists in the input rail. That's why it holds 19 volt. Here we have 3 volt 5 volt circuit. So as you see here in the schematic, we have the first channel for 5 volt and the second channel for 3 volt, as you can see here. So we have plus 3 volt always. This is the first channel where we have IC, two MOSFETs, inductor and electrolytic capacitor. Here in the motherboard we have the IC, we have inductor, we have electrolytic capacitor and two MOSFETs. The same, two MOSFETs for 5 volts, then inductor, capacitor, and we have the IC. As you can see here, for 5 volt we have the IC, two MOSFETs, inductor, capacitor. So this is basically the main component in every circuit. So let's go deeper and see exactly the references, the component references. After that, I'm going to plug the adapter to the motherboard and then follow the voltages step by step. So let's begin, for example, with plus 5 volt. So as you can see, we have the IC. The reference for IC is PU1000. So let's see here, PU1000. As you can see here, we have PU1000. So this is the controller IC. Then we have two MOSFETs, as you can see. Then we have inductor PL47. So let's see the inductor. We have PL47. So this is the inductor for 5 volt. Then we have, as you can see, PC1014, exactly as we have here in the schematic, PC1014. This is electrolytic capacitor with plus and minus. We called it sometimes polarized capacitors. Its capacitance is 220 microfarad, 6.3 volt, 6.3 volt and 220 microfarad. Here basically we have plus, as you can see here, and we have minus. This mark basically refer to minus, plus and minus. Now let's see these two MOSFETs, PQ PQ97 and PQ99. So let's see the back of the motherboard. So here we have PQ97 and over here we have PQ99. Okay, so do you see this component? This is inductor PL48. So let's go to the schematic. As you can see here, we have PL48 and we have B plus 19 volt will be passed through PL48 in order to be applied to this voltage regulator and of course to generate plus 3 volt. And as you can see here, we have RT8205 B plus. Okay, means this B plus is this, means 19 volt. This is the same voltage that is applied to plus 3 volt channel will be also applied to 5 volt channel. As you can see, we have RT8205 B plus also will be applied to this 12 voltage regulator to get plus 5 volt always. So if you didn't get, for example, plus 5 volt always and plus 3 volt always, you should check here 19 volt. So let's do it right now. Let's plug the adapter and check 19 volt here as B plus. B plus always means 19 volt is the voltage coming from the adapter. Okay, so let's check 19 volt right now. So please let me plug the adapter. So this is the power connector. You will find it always next to the battery connector or to the power jack. But here we don't have the power jack in the motherboard because we have the cable, the extension. So let's plug the adapter. Now the adapter is plugged. By the way, this is the charge IC and switches. We're gonna see the circuit in the next video. So I'm going to set the multimeter to 20 volt DC because we have output 19 volts, 3.42 amps. Means we gonna select 20 volt in the multimeter. So let's select it right now. So 20 volt DC is selected. So we have the 3 volt 5 volt circuit. So in the back of the motherboard we have this inductor PL48 as we have in the schematic PL48. We have to find here 19 volt. Without this 19 volt here, we will not get plus 3 volt always and plus 5 volt always. So let's check. So this is the inductor. Let's look for the ground. We have the ground everywhere in the motherboard. This here hole is a ground. This one also. This one also. So I will put the black probe here in the ground and then check this inductor. Let's check here. As you can see in the multimeter, we have 19 volt. Okay. I'm going to teach you how to test ICs using the multimeter. You're going to learn all about integrated circuits. You're going to learn what is integrated circuit inputs, outputs, integrated circuit pinout, references, circuit diagram, how to troubleshoot failed integrated circuits, and much more. So let's get started. So we're gonna discuss integrated circuits in laptop or computer motherboards, into tablet motherboards, cell phone motherboards, routers motherboards, and other devices motherboard. So the purpose here to study many motherboards is to understand 100% all about integrated circuits and how you deal with integrated circuits using the multimeter. So let's dive in. Of course, we're gonna also use the circuit diagram in order to understand the hardware parts, okay, and the soft parts. So first, guys, let's take a look to integrated circuits, an overview about integrated circuits in the motherboard. So you are
So for integrated circuits, as you can see, are the big ICs in every motherboard. Okay, so basically my videos are for beginners, intermediate level and advanced level. That's why sometimes I teach you some basics. So for advanced and intermediate persons, don't panic when I explain some basics, because also beginners matter. And more than 60% of my followers are beginners. Okay, so as you can see here, always the big component here are ICs, like this one for example. This is the Super IO IC. Here, as you can see, this is basically the laptop motherboard. Here we have the clock generator IC. This is the BIOS IC, and over here this is MOSFETs. So do you see, as I told you before, okay, so the BIOS always is bigger than the MOSFET in terms of size. And over here we have chipsets, as you can see. So the same working principle in every motherboard. For example, this motherboard is for tablet, as you can see. Here we have, as you can see, this is the ROM or the BIOS. Here we have the CPU, here we have the RAM, and over here we have the power IC, as you can see. Do you see? Always any IC you will find ceramic capacitors around it. As you can see, the same also for, this is basically the seal foam motherboard. As you can see, we have ICs over here. Okay, so the same working principle, and as I told you before, we're gonna study this. Always you will find ceramic capacitors around the ICs. I'm going to teach you why exactly, and how we can use this ceramic capacitor to detect whether the IC is good or not. The same also for the router. As you can see, here we have IC, the processor over here. Here we have another IC, we have ceramic capacitors. Here we have other ICs. This is basically the RAM. Okay, so we're gonna study all this. So first, let's discuss how to identify the pin number 1 of the IC. So always you will find for any IC, as you can see, a hole over here. Do you see, for example, for this, we have this hole over here. We have those here, but this is the hole. That means this is the pin number 1. Or we have this triangle, as you can see here. So this is pin number 1, pin number 2, 3, etc. For this IC, for example, this is basically the BIOS. Do you see? We have a hole over here, and we have this mark, means this is the pin number 1, 2, 3, etc. The same, for example, for this IC, we have this hole here, and also this mark here, means this is pin number 1, 2, 3, etc. And for this IC, as you can see over here, this is basically the audio control IC that controls this probe, as you can see, for audio, that controls this connector for audio, as you can see. So this is the audio control. When you find, for example, those connector or ports are not working, means you have problem with this IC. I will show you how to test it and to fix it. Do you see? Anyway, here we have this hole, and this mark here means we have the pin number 1, 2, 3, and so on. The same for this one. We have the mark here, okay? So if we go to tablet motherboard, as you can see, the same working principle. We don't have a hole, but we have this point. This dot here means over here we have pin number 1. The same, for example, for this processor, we have a dot here, okay? The same here also we have here dots, okay? So for the seal foam motherboard, as you can see, we have the same working principle. Let's see, for example, this IC. As you can see, we have the dot over here. You see this dot means this is the pin number 1. And as I told you, always we have certain capacitors around the IC. Here also we have the dot over here, means over here we have pin number 1. So for the router motherboard, also we have a dot over here. Do you see this dot? Means this is the pin number 1. And if we go here to this chips, this is basically the RAM, we have a dot over here and a dot over here, means this is the pin number 1. And over here, as you can see, we have a clear IC, as you can see, where we have the dot here, do you see? And over here we have 1.
Do you see here 1? Here we have 1, 2, 3 until 32. Here we have 32. Here we have 33, and as you can see 64, 65, 66, 7 until 96, as you can see, and 97, 98 until 128. So this processor basically has 100. This IC basically has 128 pin. So I want to share with you here a very important tip. If you focus here, as you can see, we have this path over here, these lines. Do you see? These lines basically are not the same as this one. So this is a bolded line. This bolded line means here we have power. Here we have VCC. And those line, as you can see here, a thin lines means this is just signals, control signals. Those also. And over here also we have control signals. But this bolded line here means this pin, the pin 64, hold VCC. So using this method, you can now do input voltage for every IC without the schematic. So do you see for this IC, for example, here we have many lines and path. This is basically for control signal. Do you see? A thin lines. And over here we have a very bolded line. This line, as you can see here, this is ground. This is not input voltage. This is ground. Okay? And over here we have control signal. So here do you see this bolded line and this also connected to the ceramic capacitor. So this is the input power over here. And here, as you can see, this is the ground. Okay, do you see the ground? So the ground is connected to the IC in this pin. In this pin also, as you can see, all these are ground. And in this pin also we have ground. This is basically ground. If I put one probe of the multimeter here and another probe in the ground, I will get a buzzer, a continuity. Okay, so this is how I can know whether the pin is connected to the ground or to power rail or is just an enable signal. So guys, if you understand this trick, you can analyze any circuit or IC. So let's see, for example, this MOSFET, as you can see over here. So this pin, as you can see, is connected to this line. Do you see this line? It's a thin line, but this pin is connected to a bolded line, as you can see. So means this is the gate. Why the gate? Because this is the control signal, a thin line. And this one, this is basically the source. Do you see the bolded line? And here we have the drain. So the power is passed from this terminal to drain to source, as you can see. And here we have the gate, as you can see. Do you see the gate? So this MOSFET also, I can even know the control IC. So this IC control this MOSFET, as you can see, because we have this line coming from here. Okay, so let's see another. So here we have a clear example, guys. Please pay attention. Do you see here we have source, 3 terminals connected together. Do you see? This path means all these 3 terminals are connected together, and we have the gate. Do you see the control signal? Do you see this path that I can follow until I find the source? Okay, so this is the gate. This pin receives just a control signal. It could be 1 volt, 2 volt, 1.5 volt, etc., etc. But here we have the source, as you can see. And in the other side, we have the drain. We have another IC, a clear IC, as you can see. Guys, this is basically the pin number 1. Here, do you see in this pin, we have a bolded line, means here it gets input voltage, the power in. And over here, do you see the signals? This is just a signals, enable signals and control signals. And over here also we have a bolded line connected to this hole, means over here we have ground. So this pin is for ground, as you can see here. So this pin is for ground, this pin is for power, and those are just signals, control signals. So as you can see, the power pin is connected to ceramic capacitor in order to be filtered. So always the power pin is connected to the ceramic capacitor. Do you see, guys? I can know about all pins without the schematic. So here I have another example. Do you see? This is basically an IC, not MOSFET. Here we have a 10 pin. Here we have a 10 pin. Do you see a bolded line? Means this is the input power. It could be 5 volt. And over here we have, as you can see, 10 path, as you can see here. If we go here also, we have a control signal here, and we have this bolded part connected to this hole, as you can see, means this is the ground. This pin is for ground. This pin is for input voltage, for VCC. Why? Because we have here the bolded line. So this is a secret that you cannot find everywhere, just in my channel, in electronic repair basics. So please, because you find like these tricks and secrets, please hit that like button. I want many likes for this video if you like really this exclusive content. And remember that your support is what keeps me going. So do you see also the audio control IC? As you can see here, all these are just control signals. As you can see, we have control signals and we have extensions, as I told you before in the previous video. Okay, and you will find usually all pins of the pins of any IC are connected to ceramic capacitors or resistors. That's why, for example, here let's look for the power where we have the VCC here. As you can see, do you see the bolded line? This bolded line means we have VCC here. The VCC is connected to this ceramic capacitor. Means if you don't find here VCC, you should check this ceramic capacitors if is it good or not, because this is the capacitor that feeds this IC with the VCC or the input voltage. So also in the circuit diagram, you will find the same working principle, as you can see. Do you see over here? This is a bolded line. So this bolded line basically means we have a high voltage over here. And those lines, as you can see, means just a signal, a low voltage. So if you pay attention here, so let's see here, guys, we have a note in the schematic here. Do you see? This line means a high power trace, 19 volts. So let's see an IC, for example. Let's see this IC over here. Do you see here? We have this line over here. This is a bolded line. We have the V voltage, the V reference. And over here, we have this line, for example. This is for compensation. This line, this is just enable signals. And for the voltage, we have this bolded line, exactly as the IC. Control signals lines, and we have this bolded line means the power for the IC, exactly as we have in the motherboard, as you can see. So these 10 lines is for just enable signals, and the bolded line here is for power, as you can see. So here, for example, if you don't find here, let's assume that the power here is 5 volt. If you didn't find here 5 volt, you should go and check this capacitor. Is it good or not? Now I'm going to teach you how to test an IC. I will give you the exact way and the final way to test any integrated circuit in the world. I will explain to you the methods, basically the 3 methods that you can use to check the IC. So the first method is, so let's get started. So here we have the IC, guys, that we gonna study, as you can see. Okay, so here we have the IC, guys, that we're going to study, as you can see. So please pay attention. If you understand what I'm going to say right now, you can understand, test and fix any IC you have.
So let's get started. So basically over here we have the IC, the integrated circuits. And as I told you before, always around the integrated circuit you will find many components, especially ceramic capacitors. So for the ceramic capacitors, there is two kinds of ceramic capacitors: power capacitors and data capacitors. For power capacitors are the capacitors that feed the IC with the voltage, like this one for example. Do you see this one? Here we have a bolded line, means the input for this IC is from here. So this pin of the IC is connected to this capacitor. As you can see, we have the path here, and the other terminal of capacitor connected, as you can see, to ground. We can even check using the multimeter. So let's put the multimeter to the continuity option. As you can see, let's check. The continuity option is set correctly. So if I put one probe here, as you can see, and the other probe in this terminal, do you see? So this ceramic capacitor is connected to the IC in this terminal. But in the other terminal, this capacitor is connected to the ground, as you can see. Do you see? Why? Because we have this path over here connected to ground. This is ground basically. So all capacitors around the IC, you will find it connected to the IC in one side and to the ground in the other side. Let's check this one for example. This ceramic capacitor also, as you can see, this pin is connected to the ground, as you can see, in this terminal, and this terminal of this capacitor is connected to the IC over here, as you can see. Do you see the path? Here we have the path. The same for this one, for example. Here we have the path, as you can see. So this also connected to this IC in this path, and as you can see here, connected to the ground in this side. This one also, here we have the path connected to the IC here and connected to the ground here, as you can see. We can even check it also, as you can see. Okay, so this information right now we will use it to find a short circuit. So because the ceramic capacitors are connected to the IC in one side and to the ground in one side, and of course the IC itself connected to the ground, as you can see, in one or two of its pins. Do you see here? These two pins basically are connected to the ground, as you can see. Why? Because we have here this bolded path, means this is the ground. Okay, so when you want to check whether the IC is shorted or not, you can just check the ceramic capacitors. As you can see, this is good. This one also is good. This one also is good. This one also is good, as you can see. If you find any shorted ceramic capacitor in both sides, means not the ceramic capacitor is the shorted component, means the IC is the shorted component. So this is basically the second method that we use to detect if the IC is bad or not, by checking the ceramic capacitors around it. If you find that many of ceramic capacitors are shorted in both sides, means the IC is shorted. So what about the first method? So the first method is by checking the heat of the IC using your finger. If the IC is bad, you will feel very hot, that the IC is very hot, is not normal. In that case, you should replace the IC using the same reference as you have here. The second method is by checking the ceramic capacitors around it, as I told you before. And the third method, this is basically for advanced people or for professional. Everyone that follow me in my YouTube channel will be a professional. Just a matter of time. So the third method is by checking the inputs and the output. Let's assume, for example, that this IC, this is the input of the IC in this pin, for example. The output, for example, is 3.3 volt. So to get 3.3 volt here, you should first receive, the IC first should receive the input signals, including here the input voltage, the VCC, for example, 5 volt. If, for example, 5 volt is missing here, impossible. We cannot get here the output. So when you didn't get the output, doesn't mean the IC is bad, is failed. No, you should go back and check all inputs. So let's make it simple in paper. So for this IC, for example, do you see this IC? Here we have the V out. In pin number 3, we have V out. Basically, V out is, as you can see, if we follow this path, the V out basically is, as you can see, the VCCP, 1.05 volt for chipsets. This is the V out. But to get this V out here, we need first inputs. So inputs, for example, like the VCC, as you can see here, 5 volt. Do you see here? We have this 5 volt is the first input. We should get here 5 volt. We should also receive power gauge. So the IC should receive power gauge. And also, as you can see here, EN means enable signals. Okay, the enable signal. Once the IC receive the input signals, okay, it will generate, as you can see here, the drive. You see here, drive, and over here we have drive. It will generate, as you can see, the drive signals to these two MOSFETs. So drive high signal to this MOSFET and drive low signal to this MOSFET, and then we will get over here the plus VCCP V out. So in order to get the output, the IC should receive first the inputs. So you cannot see here, for example, if I didn't get here 1.5 volt plus VCCP means automatically the IC is bad. No, you should check the inputs first. So remember, guys, we have IC. Okay, let's summarize a little bit. Here we have IC, integrated circuit. This is for beginners. Okay, this IC, as you can see here, has many pins, inputs, outputs. Okay, here we have inputs, and over here we have outputs. So output, for example, it will generate 3.3 volts, and also, for example, 5 volts. But for inputs, as you can see here, it needs the VCC, 19 volts, for example. It needs also some enable signals, enable 1, enable 2, about 3.3 volts, 3 volts. Also, the IC need the power gauge, okay, the power gauge signal, and also other signals like V reference, and also other signals like shutdown signal. So basically this signal is to protect the IC. When the IC becomes hot, very hot, this signal will be activated and the IC will stop working. So all these signals and other signals are inputs. So if you use your multimeter and check here and you didn't find 3.3 volt or 5 volt, does not mean the IC is bad. What should we do is to check the inputs. So to check the inputs, you should first refer to the data sheet. You should have the data sheet of the IC. So this is how you can check the third method. So the first method is by checking the heat of the IC
use the ring finger. If you feel that the IC is very hot, means the IC is bad. So the second method is by checking the ceramic capacitors around the IC. If you find that the ceramic capacitors around the IC are connected to the ground in both sides, means the IC is bad. The third method is by checking, as you can see here, the inputs and the outputs.